Good day, panel. This is the thesis presentation of Optical Differential Diagnosis using Image Analysis, presented by Alvin Pequina, Luigi Ehelia, and Raymart Maloya, under the supervision of Engineer Hannah Lea Angeli. The first case that we will showcase is conjunctivitis. Conjunctivitis is known to have a very red irritation towards the conjunctival area of the eye or the white area of the eye. As you can see, this is our GUI, a very simple 5-button GUI. It consists of the left eye and the right eye, each having two separate buttons for the start camera and capture, respectively. So as you can see, we are using an HD smartphone for our camera to detect any eye datasets that we would like for it to detect. Once the start camera button was pressed, it will now gather the camera and now you can start capturing. After clicking show results, it will take time to show the corresponding result. And for this one, for the left eye, it shows conjunctivitis at 99.25% probability. And the right eye shows also conjunctivitis, which shows with a great probability. So we will showcase all of the diseases twice, and this will be the second set. As you can see, that actually took time. The result for the left eye is 98.93%, and the right eye is 88.59%. This is the second case, known as cataract. Cataract is known to have a very whitish, the iris area or the black area of the eye. So we will now show our first data set. Once two pictures have been captured, we can now process the result. It takes about 5 to 7 seconds to process the proper result. Now the first result is the cataract at 97.78 probability, and the right eye also shows cataract at 99.82%. And now we will be showcasing the second testing for our cataract. And now two pictures has already been captured. We can now yield the result. This will take around 5 to 7 seconds. As you can see, for the left eye it's 99.15%, and the right eye, that is 99.74% cataract probability. And now for our third presentation, it will be the healthy eyes. Now for this one, we will be using a real eye, and we will be using the eye of Mr. Benji Ehelia. Just like the same process, we will have to start the camera for each corresponding eye. And as you can see, we are using a real human eye this time. And that is it for the left and right eye respectively. We can now yield the result. Now, assuming Benji have a very healthy eyes, it will actually show that the result is actually a healthy eye. So the healthy eye, the probability of the healthy eye for his left eye is 88.52%, and for the right eye is 48.20%. And now for the second testing, still using the same eye, just with a different angle, and we can now yield the result. And now the result came as the left eye having 86.99% healthy, and the right eye now having 83.60% probability of being healthy. And now our fourth case will be glaucoma. This is quite similar to cataract, so it is actually quite a challenge for us doing the program for this one. But the cataract shows the white surface a little bit smaller. It's actually a lot smaller compared to cataract. That's how we have differentiated glaucoma and cataract. Now, just like the same process, we have to start the camera for both left and the right eye and start capturing it. Now the result came in as glaucoma with a very high probability for both left and the right eye. And now we will showcase a second testing. And now for our second testing, it still shows glaucoma, but the probability dropped for the left eye at 93.32% and 89.54%. And now we will be showcasing uveitis. Uveitis is quite similar to conjunctivitis. The difference is there is quite an inflammation inside the iris and it's quite visible outside. As you can see, there's a bit of inflammation in the inner dark area of the eye or the iris. For the right eye, the inflammation is actually a lot clearer. As you can see, uveitis for the left eye is 74.31% probability and the right eye is 92.17% probability, as the inflammation for the right eye is actually much more vivid. For the second testing, uveitis shows at 56.12% probability for the left eye and the right eye is around 91.34%. And now we'll be showcasing keratitis. Keratitis is known to have a very red inflammation at the white part of the eye as well as the iris, the black part of the eye. As you can see, there is an inflammation. our first testing, it does show keratitis for the left eye at 87.60% probability, and keratitis also for the right eye with a great probability. Now for the second testing. And now for the second testing, the left eye is at 76.70% probability keratitis, and the right eye is at 74.02% probability keratitis. So that pretty much sums up our presentation. If there are any upgrades that we would like to have, that is for us to have a very good hardware that would eliminate the lighting. The lighting actually causes reflection towards the eye, and that actually fights for the probability of cataract and also glaucoma depending on the angle. And also, since we are using TensorFlow as our algorithm, we will also need to have a lot more datasets to increase the accuracy by a lot. And thank you so much for watching. This is our thesis presentation. Thank you so much. Have a good day.